Hello, this is David Hilster. We are live. I'm here most Fridays when I can from 9 p.m. to about 10:30 p.m. Fridays on the East Coast time here in the United States. I want to thank all my subscribers, the new subscribers subscribing to my channel. Yes, I have taken some time off from these long editing videos. I'm in the middle of one. I'm not sure I'm going to ever end that one. I've said this a number of times, but today I'm going to be talking about some subjects here. I thought an interesting article that came up this week is an article that actually is entitled "New Study Says Cosmic Acceleration and Dark Energy Don't Exist." It doesn't. I can't even read. But this is something that's a occurring theme with people who are critical thinkers, is the cosmic acceleration and dark energy, which I'd like to actually call dark mass, because energy is a concept. It can't be real. At least for those of us outside of the mainstream, we talk about the very important concepts of energy being a great concept in physics that we can use to sort of translate work from one type of system to another in the universe, but actually that energy itself as a real thing doesn't exist. And that, so when they're talking about dark energy, we're talking really more about dark matter. But I'm going to take a look at this article. I think it's good to start out with here. And it says, an Oxford scientist claims a Nobel Prize winning conclusion is wrong. Now, this isn't shocking anymore. These things are coming up more and more, which is quite good, in my opinion. And if you are paying attention at all, you can find these kinds of articles. And sometimes they actually have, well, more unlikely to find that these articles, in fact, talk about real problems that we in the dissident or critical thinking community see as real problems. A lot of times they just substitute one nonsense with another nonsense. But I think in this case, it's pretty interesting to see what's going on. But hello, Tommy Bird, and hello, Axeman. Good to see you guys. And we also have available, of course, our live ability to come here live. If you want to talk to me directly, you can have some questions or discuss something with me. I'll be happy to do that. So you can go to live.dissidentscience.com, and that will bring you into our waiting room, and I can bring you on and we can talk. If you don't want to show your video, that's also fine. You can put in whatever alias name if you're fearful because you work for some an accelerator, or you work in some place where this could jeopardize your job. Then there would be no problem. But you do want to check out my documentary film. If you're interested, you can go to einsteinwrong.com. Spent almost 10 years making that thing. It's a very interesting film. And also, if you're interested in just reading on the internet about what I call becoming science woke from the CMPS, we put together a great website called Science Woke. But so those are some of the things you can go to if you are so inclined to learn more about how to become critical thinkers in the area of science. And we certainly need more of them. And there are quite a few people out there. So again, hello, everybody. And I've got, I'll see, I be me. Let's see, here we go. We can put some things up here before we start. It says dark energy and dark matter are officially termed fudge factors. Yeah, absolutely. That's actually a good way of putting it. We use dark energy and dark matter because we can't, in fact, answer questions of things that we call anomalies. And dark matter, for those of you who don't know, came from the fact originally that we thought that the stars at the edge of galaxies were traveling at a speed not predicted by Kepler or Newton, and therefore there must be some dark matter somewhere or dark energy. Let's just again talk about dark matter. And in fact, that's what they are looking for and have been looking for many years. And I will guarantee that someone will supposedly find it and then probably win a Nobel Prize for it. I think some Nobel Prize has already been sort of awarded for that. But I do have a video on that. I will talk about it later. If you haven't seen it, just look up Dissident Science and Newton explains dark matter or something like that. Again, I'll show you that, but I want to go through this article first. But absolutely, I sort of agree with that. And here we go. Let's take a look at this article. So it says, new study says cosmic acceleration and dark energy don't exist. Well, I'll have to applaud them at least in saying and having this article out there. Now we'll find out whether or not this is just one nonsense substituted for another nonsense. So the idea of cosmic acceleration and dark energy, for those who don't know me very, very well or don't know people who are working outside the mainstream, the Big Bang is pretty much thrown out. There's just too many problems with the Big Bang conceptually. And then also dark energy or dark matter, a lot of us we can explain that with Newton. We don't need dark energy to explain the what we see in the universe. So let's go forward here. It says this is a type LA supernova remnant. That's what this picture is. That is a supernova that exploded. There was a supernova in 1987. I'm not sure if this one's where we could actually see the thing almost from the beginning. But anyways, physicists, it says, paper by Oxford physicist Subir Sarkar and his colleagues challenge how conclusions about cosmic acceleration and dark energy were reached. Great premise. I agree with that. Physicists who proved cosmic acceleration shared a Nobel Prize. Sarkar used statistical analysis to question key data, but his methodology also has detractors. Of course, that's at least good reporting. They're talking about both sides. So Matt Reek, no, it's not a coward. Oh, here we go. We'll talk with him real quickly here. Come on, Dave, don't be a coward, debate me. Well, first of all the logic I've seen you type through here has shown me that you don't debate. You have no debate skills. So it has nothing to do with, I'm not upset, I'm not emotionally, this is not an attack. I just have not seen from you any ability in debate, because I did take some time to see your comments, and they showed to me it's not worth my time, especially not worth my audience's time. So here we go. There's nothing to beat or not beat. Here's I do want to put this up there because people don't think you should be easy, Dave. Well, see, that's the whole problem. When you really talk with critical thinkers, what we're interested is in trying to find out how the universe works, what problems we have with mainstream science. This isn't winning or losing. It's stupid. The truth of the matter is, we human beings have theories. They're all wrong, and some are less wrong than others. And the idea that people are right or wrong, I agree with Neil Adams, who is an expansion tectonist person. He says we're all basically owners of part owners of the truth. So the whole thing about debate is not the question of whether or not you win or lose or whatever, but it really has to do with really discussing with people your critical thinking of the universe, what they are saying, and then discuss what points they're making. Whether we're showing, for instance, Einstein is wrong, Einstein's special relativity or general relativity is wrong. The theories are not all wrong. Yes, they are. Absolutely, they are. The reason is because you can find exceptions for all of them. Absolutely. I mean, the closest person to, in my opinion, the closest theory, more or less, but even that's not true either. It's Newton, because his laws of movement, opposite, for every action there's an opposite reaction, inertia, those kinds of things. We even discuss those. So anyways, I'm just not going to debate you, Matt. I don't see any interest. I'm absolutely interested. I had some talks with some people who came on. My first time I came live without announcing it, and it was really great, because if you're really trying to look for truth, it's certainly it's worthwhile endeavor to talk. But let's get back to this article, because I just want to make sure we can. I'm watching the comments, so. Okay, let me get there. It says, Dave, can you tell me where to find your documentary? Absolutely. Very worthwhile, even if you are not into the math, or I actually show 3 cases of where Einstein's wrong, at least 3, I think, by some very well-known, or where very well-studied and titled people. So if you go to EinsteinWrong.com, you can go see it. I think it's like $3 to rent. The reason it costs $3 to rent and $10 to buy is digitally is that I did have investors for this film. It was almost about $150,000. I made it between 2005 and 2013. Well worth your while to watch. It's very entertaining. The first thing I did was make sure it had an very interesting storyline, and it does. So even people who are not into science, I did screen it at several times with big audiences, one in a real theater. It screened extremely well. People really enjoyed it, so take a look there. All right, let's go back here. So Sekar, they're saying he looked at a statistical analysis. So is our universe expansion speeding up? Well, there's the first problem we have right there. They're saying, is our universe expansion speeding up? Well, if you are a person who's a critical thinker and you've been outside the mainstream for a while, like I have for almost 3 decades, talking with some of the most brilliant critical thinkers, in my opinion, around, we all are agreeing that there is no reason to think that other than our models are poor, to say that the universe is expanding at all, and that comes from redshift. And of course, if you want to look up what's Seeing Red by Halton Arp, go to sciencewoke.org. You can take a look at that and look at anything by Halton Arp and the whole idea of the expanding universe based on redshift. Why is it, for instance, why do I say that? How can I say that? How can I easily explain to you as an audience, maybe those who are new to critical thinking and cosmology and physics? Well, the way I put it is this: how was it that we, by luck, happen to look everywhere around on our Earth in all directions towards space and see redshift everywhere? Because that's where the idea of expansion comes from. And there are many explanations other than expansion for the redshift that have to do with light. If we have in the standard model no real physicality for light, and we can't say what it is physically, and if we don't have what light is physically, how can we say that what we see and the reaction of light, that the redshift isn't simply an intrinsic, is part of the intrinsic nature of light? One of the things that Glenn Borkert, who I would recommend you guys reading on infinity, he says that there's nothing that you can send through the universe that's going to go infinitely forever. But we have that in the standard model. And if you ask a physics teacher, you say, if you shine a light out into the vacuum of space, it's going to travel at sea forever. It wouldn't slow down. Now, if the idea that light actually does slow down because it's a physical thing, if it's photons, for instance, that have actual mass, or there are waves of particles like in the particle model, or there are waves in an ether like in ether models, none of which have been shown one is right over the other, well, then there's got to be some mechanical effect there that would make it slow down, and or or something happened to the actual the shifting of the color of the waves, and therefore you can explain what people say is the expansion by simply the nature of light. So one of the ideas is tired light, and the idea again is nothing in the universe will go forever. This idea that when you out in space and you push it, and it'll go forever. It'll will be 100 billion years from now, it'll be going the same speed in that same direction. That's just not true. There's just too much out in the universe. Nothing is empty in space. There's stuff in space all over the place, because if there's gravity in space, there's a force, and if there's a force, we believe there's a physicality to what that is, et cetera, et cetera, et cetera. So the idea is our universe expansion speeding up. I've been on the first sentence of this article, and the reason I say I'm on this first sentence is because, in fact, this is making an assumption. The person writing this is making an assumption that universe expansion is a fact. So, I see there's lots of. I'm going to come over once in a while, take a look at the comments. I know you guys are talking about things here. I'll look for any questions as well. But if you want to come on and talk directly with me, all you need is a smartphone or a computer and earbuds, and you can actually come on and we can discuss something. All right, let's go to the second sentence, see if we can get further here. The 2011 Nobel Prize went to 3 scientists for proving just that. Okay. I'm not going to be able to get through these articles, and this is, again, one of the reasons I'm here, and I have my YouTube channel is to get you guys to be your sort of science therapists. You're trying to show you how we critical thinkers think, and if you were to go to one of our conferences, we'd be stuck on the first 3 sentences, because all these things that they write down as facts, we don't believe so. So this is a 2011 Nobel Prize went to 3 scientists for proving just that. You cannot prove any theory. Einstein even said that. If you're an Einstein fan, and if you worship Einstein like many people do, unfortunately, because he was just a human. He was fallible. In fact, his special and general relativity, according to many people, are wrong. And the reason we can say that is we have experimental proof that it's wrong, and no one wants to listen to it. If you want to listen to it, that's great. But special relativity, the Sagnac effect by Dr. Cynthia Whitney. She got her PhD at MIT. Go to sciencewoke.org. Go there. And let's see, sciencewoke.org. Look her up. Look up Cynthia Whitney. You will find out that she got her PhD in special relativity, physics, math, and special relativity. Her first real job was to apply it to a circle, a gyroscope. One of those circular ring gyroscopes or something like that, and that requires that light goes around. And she was all excited to apply the special relativity that she had written her paper about, her dissertation on. And guess what, folks? It didn't work. She is now, and has been for many years, our chief scientist at the CMPS, the Chappell Natural Philosophy Society. We have another scientist, Dr. Edward Dowdy, a brilliant scientist who is retired from NASA, who worked in the laser sighting, I think it was called laser sighting division of NASA, who is one of the few people that says, guess what? Starlight does bend within coronas of suns, but outside the corona, they do not bend. Again, go to sciencewoke.org, look it up, and we have basically it violates general relativity. That is, outside the corona of the sun, light isn't bending according to general relativity. That is proof against, which you can have proof against. You cannot proof for. You can have something support a theory, but if something does not support a theory, that some data that does, you can say you've proved it wrong, or proved it it's got problems and you got to fix it, or throw it out and come up with something new. But again, so the idea of proving that there's expansion is a false statement, because you can't prove anything. Again, Einstein, if you read him, you will find out he says basically the same thing. Says you can I can have 1,000 experiments support my theory, but it just takes one to bring it down. Okay, let's see if we can get to the third sentence. But what if the evidence they used to come up with the conclusion was wrongly interpreted, and the supposed cosmic acceleration is simply an artifact of our movement through the local part of the universe? Well, that's interesting. What I like about that sentence is that what they're now stating is probably these people who are, in fact, questioning in this title, questioning cosmic acceleration and dark matter or dark energy, are saying that, well, we have movement through a local part of the universe, and that's why we're thinking we're seeing acceleration. So that's a genuinely a good explanation, a counter explanation for why, in fact, there may not be expansion at all. And I did talk about another one earlier on. So let's keep going. In the big picture, there's no speeding up. What is also there? So again, I would disagree even with the people who are saying there's no acceleration. What they're saying is there's still expansion. So my guess is that the Oxford physicists, these guys, the Oxford University physicists, Subir Sarkar and his colleagues, are big bangers. Well, people who believe in the Big Bang, got to be careful. It's not actually a great way to say that, but anyways, I would say that's just reading. Again, I'm reading between the lines. I do this a lot in my I've done this a lot in the beginning of my first videos. I did this as recording, but it's one of the things I like to do is go through these and tear them apart so you guys can do this yourself. It was really interesting. My mother, God rest her soul, she was in my film Einstein Wrong. And that makes the idea of my film was simple, to take my mom to meet all these scientists who were supposedly showing Einstein wrong and other things wrong, and to see what a layperson would think about all this. And in the end, she got very good, and she would read through these articles and says, Dave, I can see what you see now. They're saying they proved that the Nobel Prize was for proof that the universe is expanding. Well, it may not be. There's really no proof for anything. All we can say is that's our best guess for right now until something better comes along. So she would be able to go through these articles just the same way as me. And she started saying, Dave, I can see now. What I used to read and think was just okay isn't. So in the big picture, there's no speaking. Okay, what is also not there is the mysterious dark energy, thought to be creating the acceleration. So you had dark mass, and then on top of that, dark energy to make the accelerating. And of course, dark mass came from the speed of stars on the edge of galaxies. It did not. And then what happens in standard physics, when you have dark anything, that's a big green flag that says, let's go find it. That's Nobel Prize. I'll become famous. People will worship me, pay me large sums of money to speak about whatever nonsense I want. And it's really a power play, and it has very little to do with truth and science. So anyways, they say, and it says a new paper from a group of physicists who take issue with the supernova-related evidence that was used to come up with the original Nobel-worthy conclusion. So here's an interesting phrase again, with the original Nobel-worthy conclusion. Of course, it's Nobel-worthy to them, but again, if you're writing an article and you're a journalist, this is praising it. It's biased, in my opinion. This is not a good science writer. Good science writer would not present this as, well, Nobel Prizes are right and everybody's wrong. Believe me, 100 years from now, we're going to go through Nobel Prizes, and we're going to have dozens that were given on things that are completely wrong and baseless. And this is not us just talking about this, folks. This is something that we are, we people are looking at. This is just spend a lot of time looking at. When we say, for instance, special relativity is wrong, it's because we've looked at it more than the people who actually try to teach it. So that's normal. For criticizing and finding problems, you end up having to know it better, because that's how you come across those problems. Let's see what some of the comments here. I want to make sure I can see I'm speaking to you, sir, randomly commenting. Okay. There's no evidence that redshift is a shift from another color. Even that is assumption. Absolutely. There's no evidence redshift is a shift from another color. Yep. I mean, we have to really go back to square one a lot of this stuff. So I do agree. There's no proof that stars are other suns. Yeah, well, the best. Yeah, I mean, you could say that. That's a the way I look at it. You can come up with any idea if you can show that. That's great. So, I to be pedantic. If people have an idea that of something in the universe, and you can show it and you can try to argue it logically, you have the absolute right to do so. And we should support each other in that quest. I think the peculiar galaxies pretty much, okay, here we go. I think the peculiar galaxies pretty much prove redshift is more of a factor of age and can't tell us much about this at all. Very good, Tommy Bird. He is a student of Halton Arp. Again, look up Halton Arp, Halton, and last name ARP. A really great man. So something you should take a look at. One of our colleagues from the CMPS. Great to see Jim Marison. He's talked at our conferences. Tired light was rejected partially because there was no known physical explanation, but instead many hypotheses have been invented with no physical explanation, inflation to support the Big Bang. Absolutely. Jim Marison is, of course, been in this for, I'm sure I would not be amiss to say he's been here for decades. So, he is very, very, very true on those kinds of statements. I'm glad to have you in here to make some points for us here. So thanks, Jim, for joining up. And if you want to join up, Jim, just get your phone out or your computer, go to live.dissidentscience.com, and you will come here and into the waiting room. No one's taking that up except for Matt, which, again, I haven't seen any reason to debate him until I find somebody who's actually, I think, will talk critical in a good debate, has good debate skills, and not just, wrong laughing and trying. I think the thing about a debate is you have to listen to what a person says and not just try to say what you think is right, and then the other person says what they think is right, and you go back to saying what. That's not a debate. A debate is I go to you and say, okay, you believe special relativity wrong. Right. Okay. Then why is it that mass increase is not seen in particle accelerators? Why is that? And people, well, that's not important. Well, yeah, it is important. So let's see. We've got Jim also saying something else here. He says Eric Lerner has a paper that shows the observed surface brightness of distant galaxies fits a non-expanding. Yeah. And in fact, the distribution. Another person who is Ray Gallucci. He is a doctor. He's a doctoral, I guess, but he's in engineering. He does some really great papers. One of the most recent papers, I wasn't sure if it's at CMPS 2019 this year or if it was last year, but he wrote a paper on the distribution of galaxies. I think it's 2018. And if you looked at the galaxies in the sky and you did measurements and just some preliminary measurements, what you found is that it looked more like a random placing and no expansion than it did expansion or Big Bang. So there are many calculations that are done that go against the Big Bang. So in place supported a lot more than just the Big Bang. Well, this is Matt. This is a problem with the standard model and the 0.1 0.01% of physicists who are theoretical and cosmologists who are theoretical. 99.9% of them are actually practical and work in the real world and don't buy all this stuff. So it's a very small part of the population. Inflation is supported because it's taken on the life its own, just like neutrinos. Even though we know why neutrinos were postulated, Dr. Karazani shows that very clearly, and they are postulated to save special relativity. Well, in fact, what happened was people started taking it off on its own, the same way with dark energy, the same way with expansion. All of those things are taken off because why? Because the people who end up staying in theoretical physics and theoretical cosmology, and who are astrophysicists, who are theoretical, they want to grab a hold of something. And so these are the things they grab a hold of, these straw men all over the place, and then they give them the life of their own. When I talked to somebody who said, I was arguing with them, they were in physics, getting a degree in physics, they said, well, yeah, of course the neutrino exists, because if without it, this and this and this and this won't work. And I said, well, if you look at the origin of the neutrino, Dr. Karazani clearly shows that they use it to save special relativity for radioactive radioactivity. And when you have that, and then we found the Buchner-Van de Graaff. Van de Graaff is a very famous person. I can't remember if it was at MIT, but they did an experiment that showed the electron neutrino in fact doesn't exist. If it did, they would have seen it in their experiment from 1946, which Dr. Karazani found in Physics Letters or Physics Reviews, a very famous publication. But people seem to ignore that, and then the neutrino takes on a life of its own. People borrow it, dissidents borrow it, everybody puts it in their models, and it doesn't exist. Karazani shows that. So yeah, of course, inflation is supported a lot by a bunch of other house of cards in the standard model, which people hold on to in hopes that they win a Nobel Prize, because they're going to talk about something no one understands, makes no sense. They ignore the arguments about the beginnings of what started. It's sort of like if someone starts a new cult or a religion and they start talking about it, well, other people get it, other people embellish upon it. Next thing you have 5 versions of it. The next thing you have 5 different stories of the 5 different versions. You have then things, and you said, wait a minute, the origin of it was for, in fact, this. And so if you take away the origin, then you don't, all the other stuff goes away. It doesn't go away because people are invested in the Harry Potter world, the unicorn world, whatever you want to call it. They've gotten PhD after PhD about unicorns. Yeah, they don't exist, but hey, we need them for the unicorn. Look, we have a unicorn migration conference. If you say unicorns don't exist, that's we know they exist because look at the migration patterns, and this is why. So it's really a big house of cards. I see Axeman, you are there. Let's see here. Fermilab does a lot of experiment with neutrinos. Oh, okay. Answer to that, Matt, is why do they here? The answer to that question is what Karazani says is a question back to you, and that is, why do they shield neutrino detectors? I'll wait for your answer. And Fermilab and all of those places. Why do they shield neutrino detectors or put shields around neutrino experiments? I have the answer. I'll come back to that. So I do see Axeman. I don't know. Have we talked? I think we have talked before. And I apologize. I'm going to see if I bring him up and see what happens here. How do I get away from these? I think I can bring up a banner and then go away. There we go. All right. All right, Axeman. I am going to say hello, and I apologize. I'm going to be 60 this month, so maybe it's but let's see if you are there to talk. Hello, Axeman.
Hey, g'day, David. How you going?
Oh, yeah, of course. I'm
Australian guy.
Yeah,
you remember me now?
Absolutely. What time is it there in Australia?
10:30 in the morning.
Oh, that's cool. That's very good. I did realize the people who won't like this time at all which I have a lot of friends, are people in Europe. Right now, Europe is not a great time to be on this live. But how you been?
Oh, yeah, not too bad. Not too bad.
Very good. And it's really interesting to read these articles. They do come across, and I have so many friends who know I've been in this for so long. They'll send me these articles. But in this case, it's interesting to see that it's really, really rare for these articles to really be and show something that would be considered in the dissident world, the people outside, our community, that really is getting at the real problems. Most of the time, for instance, this article that we are seeing here is an article that's talking about, well, it's not accelerating, but it's still expanding. And so it's and unfortunately, when you do see these articles, I always have hope. I'm always an eternal optimist that these things will actually yield something that will, in fact, say, "Oh, there's a crack in the universe."
Do you know what a limited hangout is?
I'm sorry, say that again.
Do you know what a limited hangout is? It's
Oh,
it's an intelligence term that means when caught in a lie or when your cover is about to be blown, you admit some truth without revealing the whole truth in order
oh,
to reestablish your credibility. You'll see
oh.
it everywhere, man. A limited hangout. When people know their story's not washing anymore, they will admit some small part of the truth in order to try and regain the confidence of the people that they're lying to.
Very good. And I am very, very, very involved politically myself here in the United States, trying to get us to the truth of the matter of things. And that is true. I mean, they always want you fighting, but I've not
Yeah,
heard of that.
divide and conquer.
Yeah, and that is really interesting. So let me write that down. I don't even know that. Say that again. It's something. Say
Limited hangout.
Okay, limited hangout.
Yeah.
Wow.
It goes along with another thing called the doctrine of change of course. And this is when they say, oh, there was a few bad apples and we made some mistakes, but we're going to do things differently now, and then just keep on doing what they're originally doing.
No, this is right up my alley. Let me tell you another thing that I really want to do a video on. And again, I've taken a break. I think it's 2 months since doing these videos where I put all the graphics. They're really nice, but my gosh, they're hard to do. And that is the whole flat earthers thing. I saw Neil deGrasse Tyson, who is what I call, he's basically a science evangelist. All he does is parrot what's in the mainstream. He laughs at
a second-rate actor, kind of weatherman,
exactly,
comedy kind of guy. He's like the funny weatherman that they bring on from time to time.
Right. And here's the interesting thing about flat earthers. So some of my subscribers have said, "Hey, Dave, tell me, talk about the flat earthers." Well, I'll talk a little bit about it. The flat earthers, I know from inside, inside information. I won't say where because I can't say where, but I was being pre-interviewed for a channel about a year ago. I ended up not going on it because I didn't feel it was worth it. Some of them I've tried, but this one I didn't. But when I was talking to the person, they had said they had talked with the people who started the flat earth movement. And if anybody remembers crop circles, remember the crop circles? Anyways, the crop circles are what, of course, people were saying aliens were coming down. They were too perfectly made. How could they be made in fields? There were no, footprints. How could they be made so fast? That's impossible. But it turned out to be an elaborate prank. Well, it turns out that the flat earthers are exactly that. Their whole idea was, let's say, okay, we're going to resurrect the idea of a flat earth. We're going to do everything we can using, social media, mass media, internet to build this up and see how far it can go. And of course, you're going to get followers, but the whole thing is they continue to do it. They continue to fight. They get out there. And now what's happening is people like Neil deGrasse Tyson, Michio Kaku, Bill Nye the Science Guy, which I happen to have met in person. These guys—
Ooh, he's creepy.
Oh, he is creepy. He is really creepy. In fact, we couldn't take pictures of him on our phone. They could only take pictures and then send us the actual photo. I don't know. I think it's because of his copyright of his own image. It's ridiculous. But regardless, all these people, including, I just saw Neil deGrasse Tyson on the progressive politics channel. What's more progressive is The Hill. It's sort of new. And he was there talking about how the internet allows things like the flat earth to thrive. And when you hear the politicians and the people here, even on the left, I'm more of a progressive. I'm not, but I am a more, I'm not a radical person. But what happened is that the whole flat earthers and the people who dispute some of the science claims, not the whole claim, but behind global warming, these people are being labeled as people who don't believe in science. And in our CNPS group, we have creationists, we have people who are who are into UFOs, all of those things. But the rule of our group is you only can talk about science. So we don't care.
I thought science was a method for arriving at truth, not a system of a tome of beliefs.
Yeah, well, the whole thing is that what I'm saying though is that this whole flat Earth thing is a prank. They're going to continue to go as far as they can with it, and what they're laughing all the way to to their pranks. This prank, they're just watching it. It's getting all the way to mass. I mean, it's become worldwide known.
Well, I don't think anything appears in the mainstream media by accident. They're promoting it in the mainstream media as a way to discredit people online who ask questions about anything.
Absolutely, and that's what you're right. And
the real purpose of the operation.
Absolutely, and that was my point I was going to make. So yeah,
be used as one more excuse to undermine the First Amendment.
Yeah, and
ongoing war on free speech.
Yeah, no, absolutely. I agree 100%. But that's really what's happening. So they're using this, and then they call people like friends of mine who are very good scientists, people who have come up with really great models, and they are creationists. But again, they think that the Earth's like 10,000 years old, but they don't write papers on that. They write papers on what they.
But we're supposed to listen to a 15-year-old Swedish girl. About a non-problem.
Yeah, and the other thing is that about global warming. One of the things I see is that when we're talking about global warming, we're talking about papers that are written about scientific papers. And in my film, if you haven't seen my film, in there I have a study that I cite that was in the early 2000s by the University of Michigan, and they anonymously surveyed 3,000 scientists. And out of those 3,000 scientists, 1,000 scientists admitted to what they called scientific mischief. And that scientific mischief was basically said, to make it sound sort of small, was that 1/3 of all these scientists admitted to changing their data that they collected to fit their outcome that they were wanting.
Imagine my shock.
I know, imagine your shock. But the thing is that people, they've never gotten any type of real, how do you say, not proof, but at least statistical proof that goes on. So the problem is that when you have people, again, on the left here in the United States, especially, but around the world, who are screaming, if you don't believe in global warming, then you don't believe in science, you're a science denier. I mean, these things are all, of
people
course.
that don't know anything about science themselves and have no qualifications in the field.
Absolutely. Absolutely. And so I think those
have never actually taken an objective look at the subject.
No, right. And the way I say is, if you are a true critical thinker, if someone has let's take 10 papers and take 10 papers on the pro side and 10 papers on the against side, and take a look at them and then argue the points to find out what's really going on.
On an even more basic level is, let's look at the source data and how it was gathered.
Right.
And the accuracy of that, and sort of consider just the size of the problem of measuring this system accurately.
Of
I
course.
think that's a really good place to start, to get a perspective on just how little we can actually measure of what goes on in the weather.
Of course. I mean, when people who know me, they know I have my YouTube channel, and then they look, oh, you got, wow, he's got some, subscribers. They'll come up to me, and they're just friends. They're not into science too much, and they'll come up to me and they go, "Hey, Dave, you look at all the science. Is there global warming?" I said, "Look, the thing is, I can tell you is, yeah, human beings are destroying parts of the earth, lots of parts of the earth. That to me is the bigger problem. But I said, if you look at the global warming, let me ask you this," and I'll ask the average person. I goes, "How far in advance can we predict the weather?" And they say, well, maybe 5 days pretty well, 3 days a lot better. It says, okay, now imagine predicting the entire planet and all the things that go on and all the chemicals that are coming up and all everything, and then saying to everyone that in this amount of time that we're going to get this kind of warm up. How do you think we can do that if we can't even get the weather right for 5 or for 10 days?
I watched a good presentation by, I can't remember the guy's name, but he talked about his communications with the European weather prediction mob that uses the most sophisticated models on the fastest supercomputers, and they reckon their models are accurate out to about 3 days over northern Europe, and that's it.
Yeah. Yeah, and so you imagine we're now trying to do the global situation.
You know about the turbulence problem with the Navier-Stokes equations?
No, I'm not familiar.
Well, the Navier-Stokes equations are what basically used to model hydrodynamics, fluid flow and
sure.
temperature differentials across fluids, but these equations don't explain turbulence. They can't predict the breakdown of a laminar flow into turbulence. This is one of the Millennium Prize math problems,
right?
That still hasn't been solved,
right?
And the Navier-Stokes equations are a complex set of non-linear partial differential equations.
Right.
These things cannot be solved by computers. If you know anything about chaos theory and complexity,
sure,
it's incredibly sensitive to initial conditions, which means we have to measure everything perfectly to put it into the model, and they've diverged very quickly based on the initial conditions, because of the complex nature of the feedbacks inside it. And then the other thing is there's no accurate, discrete from continuous conversion in the maths. You can't model continuous mathematics in discrete mathematics that a computer can do. Information is lost. You have to just find a sample size and a grid size for the space you're working in, and there's always going to be holes in the grid.
Yeah. In fact, I'd like to put this up here, what you're talking about. This is our Science Woke website. Again, if you want to learn about people and the critical thinkers, just a great variety. One of the people I wanted to just mention what you were saying, X-Man, is Glenn Borchert. And Dr. Glenn Borchert has introduced infinity into the philosophy of science and actually the physicality of science. And one of the things about infinity is that he has what he calls microcosms, macrocosms, and unicosms. And basically, if you read his book, which is a must read for everybody in science, in my opinion, a must read. Basically, he's saying that everything affects everything. And not only that, if you believe, like I do believe, that the universe is infinite, not only in space and direction, in 3 dimensions, but also in size, meaning as you go down, no particle can be the ultimate particle, because you have a problem of how can that ultimate particle organize itself by itself. So the whole thing is, he says there are no partless parts. Now, if you look at that, that means that you have, when you're going through space that you think is empty and there's gravity, well, that's got to be a force, it's got to be something. If it's a particle, then that particle is made of other particles. And he has an ether theory. That's what he is, an etherist. My dad and I have a particle theory. It's very similar. We have, particles going all the way up and all the way down, getting getting bigger and smaller, and he does the same with ether. Now, what that means is that when you're looking at a system, like the whole, whatever you look at, whatever you're looking at, there is an infinite amount of stuff that's happening around it. You
There are no
can't.
closed systems in nature.
Yes, exactly. You can't get to it. So what you do is you sort of
systems only exist in physical models, and it's because we can't calculate an unclosed system.
right. And so what we do is we try to throw, as my dad says, he's an electrical engineer, and he says we try to cobble together some basic equations and hope that we can do some predictions in this space that's going to be useful to us. That's basically what we try to do, because the moment we
start with a simplified building block model, like Bohr did with the hydrogen atom, and then build that up by complexity and extrapolation from a very simple, limited model.
Yeah. So if you read Borkert, you're going to get this in a philosophical sense, that what you have is an infinite universe, both up and down. So the moment you say I'm going to stop at the atom, you're stopping at a place where if you were to continue, you would go infinitely down. Atoms are made of smaller parts, and those parts are made of smaller parts. You eventually, you have to, pick a
models can be useful, but they have to have clearly defined limits.
Right, of course.
They apply.
Right. Absolutely.
But they don't actually create reality. And unfortunately, we now live in a world full of theoretical physical physicist kind of people, and the masses that they're brainwashed with their rubbish, that seem to think that somehow abstract ideas actually create reality, and that reality is defined by these abstract ideas that people invent.
Yeah, absolutely.
Completely got it backwards. The cart before the horse.
Of course. I remember when I got
this Matt bloke who's been crapping on in the YouTube comments. He's obviously one of those. He said something about, we have proven it must exist.
Right. Yeah. Well, it's funny because
it must be there because the math says so. Forget about observations.
Right, exactly. Forget about all the counter examples we give them, which they ignore.
Yeah. Well, don't question your assumptions.
But I had this. This is one of my older versions of a book of my father and I's model, which is absolutely everything's physical. Everything is physical. You can't have anything with a force that isn't. But when I handed it to him, and he just was looking at the idea that gravity was a push force from some mass, which my father and I believe. We believe everything's Newtonian. It's just that we're afraid to try to make models from it. And so he gave me the book back down, and he sat on my desk. I couldn't get past the first idea that gravity is a push. It's an attraction. And I tried to explain to him there's no such thing as a pull. It's just a semantic thing of a push coming toward you. And but regardless, he said something. I said, well, math isn't physics, the physical world. Math is a system, an imperfect system. In fact, our real number system is really screwed up. But he says no.
And then our way of putting it onto computers is a bit messed up as well.
Right, but what he said to me, I said, well, we'll take general relativity and tensor equations, and he goes, I said, well, tensor equations can just, supposedly describe space-time, which supposedly will give you a sense of what gravity, a body through space or, next to another body would happen, how that would, what we would end up saying would attract. And he goes, well, it said, what is that? I said, space-time. It's a fabric. It's a goo. It's a rubber sheet. What is it? And he says, no, it's tensor equations. I said, no, but tensor equations math. He goes, no, tensor equations are physical reality. He couldn't, and I'm looking at this guy, and he's a brilliant computer scientist, and I'm looking at him like, you're joking, right? Think about what you're saying.
There's an Orwell quote that I've come across a few times recently. Some ideas are so bad, you have to be very intelligent to believe them.
Well, what that comes from, Axeman, is that what that comes from is that something I contend, and that is the same way politicians tell us that the income inequality is a very complicated problem. It can't be solved simply, which is not true. Which is true. It can be solved simply, but they say it's not. The reason they say that is because that way you don't understand it. We then will solve it. You don't know what's going on. Well, it's the same way in physics. The idea there is that if you don't accept special relativity, or you don't accept the Big Bang, or you don't accept plate tectonics and accept expansion tectonics. The reason you don't is you haven't been schooled. You don't know the complexity.
Priests have been doing this for thousands of years. There's a kind of relevant Bible quote, woe unto ye lawyers and Pharisees, for ye have taken away the key to meaning and prevented them from entering, that you have not entered yourselves.
Yes. No, it really is amazing.
Things never really change much.
No, it really doesn't. And I think what's really sad is that here's somebody saying that science is now a religion as given to us by infallible talking heads of media. So I bring back the art of asking a better question. Yeah, I mean, I think what's really great is we are really at a time where we have the ability, and that's why we came up with this. I know it seems a little trivial, but it took us a couple of years for that was one of the big pushes I pushed for, and a lot of us worked a lot on, is the Science Woke website, because people, when they're talked to by the media, they're not told that there's a group of people who fight and they're being repressed. They don't even know those stories. Those don't exist at all. They don't know what is being claimed to be wrong with mainstream science. They don't have any of those arguments. So there was no place for them to go. And so this Science Woke website, which is doing quite well, we've only put it up, well, I'm pretty sure it was less than a year ago, but it's almost got 20,000 page reads, which is pretty good. Moving along without anything out there really pushing it. But the whole idea is people don't get exposed to knowing that a person went to a college, has very good mathematics background, as Stephen Crothers, and Stephen Crothers goes and he's a fellow Aussie, and he's in the physics or cosmology department and wanting to write his dissertation on the problems with Schwarzkopf's, I can't remember the exact name. Schwarzschild, right?
Schwarzschild radius,
exactly. And he
was trying to pin down the definition of it in the maths,
right? And so he has brilliant arguments. I mean,
which black hole are we talking about? Which version of the mathematical entity called a black hole? Because I think he points out at least 3 different versions of the black hole.
Yeah. Oh, well, here's the thing. I'm going to put them up here.
It would seem to me that a simple way of explaining it is that they've got divide by zero errors in their maths.
Oh yeah, well that's not the only thing he found. What's really shocking, I've seen several.
I was actually at music school with his brother.
Oh really?
Yeah, and who's a drummer, and he was telling me in about 1992 about his brother getting denied his degree because he questioned Einstein and that he'd done the maths and worked it out. And I was pretty skeptical about it at the time because I was not aware of, I
right.
believe
You weren't science woke
at that point, like everybody did,
Right. Yeah, and here's his story. He wrote it, and we have it copied here with his permission. Kicked out of the University of South Wales, March of 2003. And when I heard his talk, I think the
University of New South Wales is a very sick and corrupt institution full of some really, really horrible people, much like Harvard or
right.
MIT.
Right. And I think what I was going to say is that it's interesting that the thing I remember during his talk that was really simple and easy to understand. And so I try to hold on to the simpler things. I've got my degrees in, calculus and all that, but I try to always come up with pretty simple ways to explain what people are doing or what they've done and what. And there's a point at which that Stephen Crowther was talking, and he got to this point in his talk, and he really made a big deal of it. I'm sure you can, if you go and watch his talks, you'll see it too. He's going along and he goes, black holes involve one mass. That's it, right? One mass. And so he's going along, and then all of a sudden in the mathematics for black holes, another mass appears and the calculations. And if you think about it, where did that come from? Why was that introduced?
There's another classic point he makes in his lecture where Einstein redefines a symbol in a separate set of equations, and then substitutes the definition that he had used in the first set of equations into the second set of equations.
Yeah. I remember that as well. He said there was some, he during his lecture, and if you haven't seen them, if you go to Science Woke, we've got all these people. We want to continue to put more. Here's a lot of his papers, 25 of them he's written. So, and we have them all cataloged. And you can see here some of his talks, ones at the EU. Those are some good talks that he puts on. It's interesting too that the electric universe 10 years ago, I've mentioned this before, but 10 years ago we worked together. We had our conferences together, the MPA at the time and the CMPS, and we organized, and it was probably one of our biggest. We did one in Albuquerque, New Mexico, and the other one was at the University of Maryland. And there were quite a lot of people there. Well, the first time we had it was at the University of Maryland, where we had a sort of a joint conference, and they were all sort of snickering the whole time about Einstein, because they said, the CMPS at this time, we get always labeled as something. In the beginning, we were labeled as special relativity is wrong. Then we got labeled as the Big Bang and relativity in general is wrong. And then when they got to us, now we're labeled as an ether group, even though we have other models. And so it turns out that at that time, in the early 2000s or mid 2000s, the first decade, they were sort of snickering at us and saying, look at these guys. They all think Einstein's wrong. What a waste of time. And then fast forward to today, including Stephen Crothers. Stephen Crothers in the last year and a half have come out with videos and explanations of how relativity is wrong. So, it's interesting that even in the dissident community, there's divisions, and that's the hardest part. It's really hard for me, and I'm really coming to the point now that I think we have to have the simplest of all philosophies, and that is, if you can write a scientifically logical paper, and you're basing it on real data or at least a real logic that looks plausible, then you should have the right to get up there and go at it and try to defend it. And the moment we start saying, well, this one isn't, and this one no, then it's not that we don't judge papers. In fact, in the CMPS, if you write one about baseball, you're not going to be in our proceedings because it's off topic.
Free and open exchange of ideas is the basis of scientific progress.
Right, and that's why we haven't had scientific progress for a long time.
Exactly, because there's no free and open debate. People won't open their data to criticism. They're unwilling to engage skeptically with their own work.
Right. Oh, and that's the other thing too, Axeman, is that one of the biggest problems we have, especially in our organization, is the closest one you're going to get to people working on other models outside the standard model. The electric universe does their work, but they have a specific thing about trying to show this electrical part only. We look at a sort of broader sense. They argue against that, but that's okay. I support them 100%.
Well, no model's ever complete, is it? It's always a process.
Of course. And
new evidence might prove that even though a model works up to a certain point,
it's always going to be that way.
That new observations aren't explained by the model, and the model might be completely wrong, and some of its assumptions may be completely wrong,
Of
and
course.
it might all need to be reassessed.
Yeah, and what I was saying is that one of the problems is that amongst the dissidents themselves, they themselves, when they get into their own model, in their little model world of their own model, they become dogmatic.
Yeah,
And
well,
so,
look at
and
Matt still ranting onto himself in the chat there.
yeah, yeah, exactly. Yeah. And that's the problem is you get, yeah, well, can I actually, let me see if I can do something. How are we doing? Let's get back to, you can't get a degree in calculus. What's this guy saying?
It's argument from authority, basically. He's going
Yeah.
on about banging on about how he works at Fermilab or has friends at Fermilab, and he's got qualifications, and he's questioning your qualifications. And
Well, see, in this, that's the whole thing is one of the I think the last edited video I did was about intellects and intellectuals and what I call intellectuals and critical thinkers.
I
Intellectuals,
don't have any formal scientific qualifications
yeah,
beyond high school. You
but
know?
but what matters, what in my film, after 8 years, I came up with one phrase. I had to come up with one phrase about what this organization that we were in the film, we were the organization we were part of. My mom was part of the film was, don't listen to me, listen to what I say, and that was my phrase. And what that means is titles don't matter. In fact, if you go to our conference, and this is honest to God truth, this is why I love our group. I think our group is the best in the world, even though it's small right now. We've actually got 350 members worldwide. But when we get, getting people together today is hard. It's expensive. But regardless, when someone gets up in front of our group and starts talking, the moment they start talking, we concentrate on one thing and one thing alone: what they're saying and the logic of what they're saying. We don't care if they're a garbage man. We have people up there who are PhDs from MIT in physics. We have other people up there. One guy is he's a retired Supreme Court justice from Canada. He was on the Supreme Court, for God's sakes. And we have other people who are up there who have no scientific degree at all. So when people are talking about, what they're saying is, you haven't been indoctrinated into the intellectual side, which is university taught. And university taught is automatically seen as to be superior and the right answer, which of course is not the way universities should be taught. In fact, a friend of mine, Luis Sarobon from Brazil, from the university across from Rio de Janeiro. He was an engineering teacher, and I called him up. I've told this story, but for those who haven't heard it, basically called him up. It's related to what you're saying. And I was talking with him. I said, look, I want to pick your brain, because he made all the students, when they picked something like the Big Bang, even though it was engineering, could pick a bigger subject like the Big Bang. He required them, and they would fail if they did not look at the positive proof for and proof against every theory that they picked. If it was a Big Bang, they had to study and give arguments that people gave against it as well as for it. After 4 years, he had to stop teaching it. The reason was, he said, and this is a quote from him, a third of the students loved it. They loved the critical thought. They're going, wow, this is really cool. I've never thought about looking to see if there was evidence against the Big Bang. It just never occurred to me.
How do you know something's right if you haven't looked at the reasons why it might be wrong?
But look what happened to him politically. And he's not even a physics teacher. He was an engineering teacher. So a third of the people...
I can imagine. He got sacked, I bet.
No, he didn't. But this is what happened. He said a third of my students loved it. A third of them just got their grade, passed, and didn't care. Another third started talking to the dean about him teaching blasphemous stuff. And so
they actually use words like that unironically, and will claim to be atheists, of course.
Yeah. Oh man, it's just man.
It's clown world. Have you heard? You must have heard of the meme Clown World.
Yeah, I have. Yes,
we live in clown world, David. The lunatics have truly taken over the asylum.
Yeah, no, absolutely.
Black is white. Fantasy is now of greater importance than reality.
Yeah.
Reality must be adjusted to suit political correctness.
It's just amazing. The other thing that's really interesting, Axeman, that you may not have heard, that I thought trying to get some, because you seem to be very well studied for as little college. I'll still talk to you even though you have no
I
degree.
studied music at the conservatorium,
Well,
and
music
I'm
is a great
self-educated.
thing.
I read before the internet came along. I read books for
Oh,
overseas,
sure, of course, of
and
course.
since the internet has given me access to all this information, I just soak it up like a sponge. And
Oh no,
develop
absolutely.
interest in many areas, and I write computer programs, and that I think helps you to develop a logical thinking structure.
Yeah, actually, I was going to say something. I have to make sure I take notes. I forgot now. That's all right. But anyways, yeah, let me take a look at some of these. I lost my train of thought. No problem. It'll probably come back. See, I actually found out in my control panel I can put people in a timeout. So I put what's his name, Matt, in a timeout. So I don't see his stuff here. I don't know if he's still ranting. If you guys can see him,
Yeah, our message deleted.
yeah. So it's good. Just looking here, Matt, is you can basically argue experiments are relevant in science. Okay, here's something interesting. What they say. You are basically arguing that experiments are irrelevant in science and that mathematical constructs supersede that scientific method. You never provide any evidence beyond citing math. Yeah, absolutely.
That's pretty much it, isn't it?
Yeah, and I mean that's one of the really great things about when we are talking about proof against. Again, if you go to sciencewoke.org, you'll be able to see that. I always try to have on hand when somebody says, "Well, what what is proof against general relativity?" And then I talk about star light not bending outside of coronas. What happened? How about special relativity? Well, mass increase isn't observed in particle accelerators, and you wouldn't believe how many people who are. Oh, I remember now. I forget. But here's what I wanted to say. Very interesting, Axeman, is I've talked several times with Dr. Alexander Unsecker. If you go to Dissident Science, Alexander Unsecker,
yeah, I'm aware of it.
Yeah, he's a really great guy. I really like him because he is one of the few people that he actually goes right in the face of David so and so, who won the Nobel Prize for particle physics, and just made him so upset that he ended up taking his microphone, walking away. So you can imagine, at least he's got brownie points for no. But Alexander's just great. He told me something that was.
What sort of science are we doing when people are getting that emotionally involved that they can't engage in a critical discussion about the subject?
Well, let me tell you why.
What about falsifiability? What about the duty of a scientist to actively try and falsify their own theory?
I will tell you the answer, and that's why I'm going to tell you. Here is the answer that he gave, which was shocking, but it wasn't shocking. But it was the first time I've heard it from a real physicist who has a PhD in physics, who's gone through the institutional side, who's obviously came to the dark side of physics to say, things aren't right. But he said this. He said when he asked this David guy, if you go and look up David and Alexander Unsecker, I can't remember, Wook or Woot or something like that is his name. I'll have to look him up. But he won. That's his interview. It's a really great interview, and where he basically gets frustrated. He said that he asked this David guy who won the Nobel Prize how he went into theoretical physics. Now I am going to totally make it into a I'm at a bar, I've drank too much, so I'm going to tell you a simple story. To put it in a paraphrasing similar example as he said, basically he said, well, I wanted to be a veterinarian because I like doggies, but I decided to be a theoretical physicist. I mean, basically what it was is that he says is the people who stay in it are and this is now my own conjecture. My conjecture is the people who stay in particle physics are the same people who are the corrupt politicians. For you to be a politician, you have to throw away morals that let people die.
I'm struggling to self-censor myself to here, David. You better change the subject.
Uh-oh. What's that?
It's just I keep noticing coincidences,
Oh yeah, but what's
these echoes.
But what's interesting is that these people who go into particle physics are the same kinds of people who go into politicians.
Indeed, they are.
They're not the cream of the crop. They're not critical
And
thinkers.
some of them go into the media too.
Yeah, sure. I mean, if you looked, it was funny because I did this.
Quite a few of them run casinos and porn fucking websites and shit like that as well.
Well, didn't Stephen Hawking go on Weinstein's famous Yolita Express and go to his island? I mean, come on. I mean, there's all kinds of things going on. So
there's a document got around on the net this week purporting to be Jeffrey Epstein's little black book.
Oh, I didn't see that. No, I didn't see that. Well, you know, I live right here. I live in Palm Beach County where he was convicted, I think, here. So
anyway,
but regardless, what I'm saying is that people who go into theoretical physicists are not.
Are you aware of this Polish guy Lobachevsky, Andrew Lobachevsky?
No.
He wrote a book called. He sort of invented this word, ponerology, which was the study of how institutions turn psychopathic. And he was, him and the people that they studied the corruption of the institutions in the communist government in Poland and came up with this general sort of view of how institutions become corrupt by psychopaths getting into positions of power where they appoint their friends into positions of power, and then the whole thing spreads. And they pathologize the whole institution.
Oh yeah, absolutely. I mean, we have a perfect pathological person here in the United States, Hillary Clinton. Come on, I mean, these people are they live in a well. Here, I don't know if you heard about this study. It came out earlier.
You must have seen the video of her bragging about Gaddafi.
Oh yeah, well that's one of thousands. Well, it turns out that here in the United States, if you happen to go against their ways, there was a great meme today I saw that she had Hillary Clinton calling 911 or no suicide prevention, and she goes, "Suicide prevention? I'd like to order a suicide." But anyways, getting back to the personalities of people who get into these sciences, is that the public is under the concept. When I talk to the public, and again, because of my movie, they'll go and watch it. They go, well, isn't it the case that if Einstein's wrong and you have evidence against it, that all the universities and the people in the universities look at that and then they decide, oh, well, maybe our theory is wrong, and they adjust the theories, or they throw them out, and they're the ones who look into that, right? That's their job. That's what they think. That's what the public thinks. That's what the public actually, thinks about what goes on in science. It's just not. It's sad. It's very sad.
They've been trained to see scientists as the new priesthood, who are unquestionably right all the time.
Yeah. Here's another
more successful than any religious brainwashing's ever been. I'd argue.
Absolutely. It says, Dave, I've been looking into theories that basically seem to say that gravity and magnetism are the same thing, being both form of dielectric acceleration. Any thoughts on this? Yeah, I mean, I can give you a pretty simple thought on this, and that is, here's the problem with the idea of the form of dielectric acceleration. Well, what is electricity? What is magnetic fields? And until you have a model that physically models all of those things, the idea that it's going to come from, that's really coming from a mathematical side. And so what you're doing is you may be combining things, but you still don't give any physicality for it. So the idea of a dielectric acceleration does that involve positive and negative? Is that something that you can describe other than putting a plus and a minus on something, or writing field lines and saying things behave with this and giving mathematics for? What we are looking for, and I think what the public looking for, and that's what my dad and I's model, for instance, I'm not here to push it. That's just, he and I are working on it. That's, right or wrong, whether it's right or wrong. But what we have a real simple rule. You cannot have anything that's a charge, for instance. You can't put a plus on this and a minus on this, and then they attract. So the idea of making gravity and magnetism are the same thing. Well, give me your physical model for gravity, and magnetism, you don't have to tell me whether they're the same thing or not. You just tell me what they are, and I'll either know they're the same thing or they're not. And in our model, for instance, the same particle is involved. It's just they're involved in different ways. Gravity is a random direction force of particles. You can get a gravitational field by taking like particles and randomly putting them in all directions, called the shadowing effect. Or magnetism, as shown by Ionel Dinu, the scientist from Romania, underwater experiments, that flowing particles or flowing fluids, which are particles, act exactly like magnets. So if you have a flowing fluid around a cylinder in like directions, they repel, and in opposite directions they attract. He shows a physical model for it. That's what we use in our model. So again, I'm not here to say that our model's right or wrong. I'm saying that it doesn't matter what you say, that gravity and magnetism are the same, if you don't have any physical model for it. If you go up and tell people that and you give them equations, they're just going to look at you and say, I'm not convinced. And they shouldn't be convinced, because this idea that what people are doing, and if you want to see the ultimate in taking the answer of this gravity, magnetism, the same thing, dielectric and acceleration, monopoles, all those kinds of things, you want to look up and talk, and you want to see that kind of thing, if that's the kind of direction that floats your boat. And I'm not saying that's right or wrong. You have the right to do that. That is with, let me see here. Where are you? Boy, don't I have him here? Where are you? Oh my goodness. I don't have him listed. Where that would be Dr. Lucas, Bill Lucas. Huh. I don't have him listed here. Where did you go, Mr. Lucas? Oh, well, that's my website. But look him up, Dr. Bill Lucas. He has the equation for unifying all that kind of stuff. So that's my thoughts. The idea, to answer your question in a short way, is that it's not a physical answer, it's a mathematical one. And in my opinion, that's not where we need to be these days. So again, that's my opinion. All righty. Anything else? See, what time do we have here? 10. Oh, wow, almost an hour and a half. But I think the topic that I'm working on for my video is, I'm not going to talk too much about it because I don't want to spoil it, but it has to do with the thing that Axeman you do correctly and I do correctly, in my opinion. And I do a lot of it. It's just natural to me. I'm a person it turns out, without my own theory for a long time, till 2015, until my dad came up with a solution for the wave particle duality, and I had collected all these other ideas and we put them together in a model. Before that, I didn't have a model, but still, even with a model, that I have a model, when I get a new book and someone sends me a new book, here's one of the latest ones someone sent me, called the Bubble Earth, and it says Space-Time Gravity and the Evolving Earth. I get all really excited because I like to see what a person has spent a lot of their life on, trying to come up with some type of system. And it turns out that I can't stay away from it, because I always have this, it's funny, Axeman, it's funny. Now that we have our own model that we're working on, and again, we keep building it because we can't break it. My dad and I half the time don't even believe it. It's right, but we can't break it. So we keep going with it. But it's funny because every time I see something new, or a new theory, or new something, it turns out that I am looking to see and read about all I can about that theory. Like Jeff Yee's theory, he comes up with new ideas and new parts of it, and I look at it. I look at how he puts the nucleus together. How is he doing that? He's doing them in spheres, and they're in tetrahedrons. They're sort of stacked up. He's got them, and I asked him about it. So I'm a person that's very different. Even though I have my own model with my father and I have our own model, I do not stop ever looking at other people's models. I just don't. And if I get a new book, I look at it and say, well, maybe this person found it. Maybe this is what we're all going to be working on in the future. Maybe this book that I got, this one here, is the one that's going to be the next big thing. And I don't see people who are working on their own stuff. It's great, but I don't understand how people can I understand you want to concentrate what you're doing. My dad and I did that for about a year and a half. But even then, I was constantly with my eyes open. And because I found, what, 90% of our models from putting other people's stuff together in a unique way. That's all we do. That's all people can do. And so, I don't understand how it is that people who are working on their own models just ignore others' models, like etherists. They're all talking into them amongst themselves, and then we have a completely different model, which is a lot less problematic than ether. And it's like they don't even care. They don't look at it. They're not afraid that our model's better. I don't get that. I don't know if it's because I'm paranoid or what. I don't know. I do have some questions here. Let me see here. David, how do you make predictions with model without math? You don't. That's the thing. That's not what I'm saying. I'm not saying that math isn't useful. Absolutely, it's super important, because once you have a model, you have to use math. So the rule is first model, second math. That's what you want. So in fact, let's see if my book here, if it says that. No, not this one. This, again, I'm not pushing our model. It's just that it says something I think that's really important. I don't need my earphones. Where is it? Anyways, I think I can put the cover up on the screen. I think I have the cover available. So let me put that there. But I'm going to answer your question here. Universehack.com. So cover universehack.org. There it is. Okay. Well, that doesn't say it. It used to say no math model of the universe, explaining the entire universe using Newton's gravity. I've come up with 1,000 different things, but actually the current title of it is extending Newton's Principia. We're extending it by three cases. But basically, what we say is that our model is a no math model. We have so many versions of our book because you can print them out. I've got one that says the no math model of the universe. Come on, I got to find it. I'm not finding it, folks, but that's what it says on the cover. No math model. And that's true. So we came up with our model with no math. You don't need any math for it. So, but once you do have a model, obviously you want math. One of the things my dad does a lot is to have I lost my train of thought. Sorry. So, all right. Yes, we have Matt coming in. I am giving him a timeout. It's just, so let's see. Models are useful. Okay, here we go. Models are useful as long as they don't prevent the user from seeing new information. By necessity, modeling must be fluid and multidisciplinary. Yeah, I think very much so. Actually, that's pretty. I agree with that. That is really quite good. I like that comment. What I like about it is they are useful as long as you don't prevent the user from seeing new information. Absolutely. It also, new models give you new insights. Our model actually gives us a very clear understanding of what we would call, why we call certain things, like why we call things electrical. What does it mean physically to be electrical? And our model says that. What's it mean to be gravity? The electric part of the universe are particles that flow together in the same direction. I mean, it's so stupid, but that's what our model says. That's going to be in our book, of course. But yeah, I agree. And it's fluid. That's why we call it the universe hack. Why do we call it hack 3.0? Is because we are hacking the universe with the model. And took us 2.5 years to hack dispersion. Why white light in a triangular form turns into a rainbow. That was a really fun hack to try to figure out. And our hack may be wrong. All right, let's see. Hey, V Darkness, it's good to see you. Where can I find your book and your models? Um, we're writing it. My dad and we're going to be moving in this wonderful place that I'm in here, which is this townhouse we have here in Boca Raton. Is actually we're selling, so my dad and I will actually he'll be moving in with us, and we'll be able to work. I have time over the Thanksgiving break, so we plan to be working on the book, and we plan to have that out next year. It's going to happen next year, regardless. We finally figured out what we had. We didn't know how to write it because it was sort of circular. So yes, the book's going to be out, and it basically, if you look at the title, it says all the phenomenon, says all these phenomena travel at the speed of light and therefore can be treated as the same particle. Light, gravity, electricity, fire, lasers, magnetic fields, electric fields, electrons, atomic bonds, atomic polarity, refraction, reflection, dispersion, and more. So we actually describe everything as a mass and movement, and even the atomic structures, all those things. We don't have the nucleus configurations and specifics about that, but we do have the mechanisms for everything, and everything has a reason. There is no magical particle. There's no charge. The only thing is moving. So anyways, I will hope to get that out soon. I know. We are live right now. Yes, sir. We are live for sure, for real right now. This is not a recording. Let's see. F Darkness. Here we go. Math is just an attempt to read what's going on in the universe. Problem is they don't even know what they're looking at exactly, and math won't tell them either. Absolutely. Mother Nature doesn't work with a calculator. It doesn't, and so true. The universe has no laws. The universe has no math. We are the ones who place those upon it. So absolutely, I agree with you. Nature does not fit into one or two equations. It works as a protocol, and everything is possible given you follow correct set of manifestation steps. Well, this gets again into Glenn Borchert's model of the universe, which I agree is all turtles all the way up, turtles all the way down. That was sort of my addition to explaining him. My goal is a lot of times to read these people who I think have immense things to say to us as in science. Try to set it, but yeah. So basically, everything affects everything, and it's way down, way down. You just have to eventually put a barrier there, write mathematics for that little unicosm, as he calls them, not even microcosm, unicosm, and then write math for that. New Thunderbolts video, Giant Jets and Electric Earth. Yep, take a look. Thunderbolts, love their organization. They are creating, they have the absolute right to go as far as they can with their model, and I applaud them, and I enjoy looking at their model. It gives us more ideas for our own model. But yeah. Oh, and we got Axeman is back. We lost him for a second. All right, let's get him back.
Yeah, connection just dropped out.
Yeah, I did see that. Yeah. So
yeah, Windows just decided to drop the local area network connection for a bit.
Yeah, I mean, I've been lucky. In fact, I bought a used computer because actually I have one I work in the supercomputing department at LexisNexis. This is my real job, but I can't use their computer because we have data on it. I can't use it for something like this. And my PC was like 5 or 6 years old, so I got this used one, which is pretty good, and it's got a SSD drive, which means solid state drive. And so I figured if I was going to use this new software by StreamYard, I had to have a better computer. So, but hey, this has been a good night so far, because I started out the first night I did it was like 7 or 8 averaging, and now we're up to over 20. So I appreciate everybody. Again, I promise to get some videos out. I've just had to take a break. Life gets in the way. But I've just been taking a look at some of the comments. Let's let's see here. Math tells you a model, doubt it. What are the chances of sunflower exist on another Earth-like planet? Slim to none. Another solar system is built in the exact same. Well, yeah. Well, this again, darkness, and all of you read Glenn Borkert. Is it the case that if you have infinity and the universe goes on forever, which I believe it does, and it's constantly, blowing, we see stars being born and stars blowing up, and we have the life cycle of all these stars. And why do we have a big bang? If that's another.
When we see the whole process there,
Yeah,
in
exactly.
all
How is it?
stages.
How is
And it's the fractal similarity at all scales that we see as well that leads you to think they're not necessarily be an end to it. That just similar structure keeps repeating forever.
Well, yeah, I think, the fractalness part of it comes to really fractals are a part of our unicosm, basically, our world where we can see too. Because if we believe, which like I believe, that there are particles all the way down, whenever object is in front of your face, has an infinite little worlds below and below and below and below, but eventually you only can see at a certain resolution, right? We can only eventually say we're going to stop here, and when we stop there, we're going to see patterns that are going to be similar. I mean, that's just the way, fractals. There's a lady in our group called the Fractal Woman, and I was looking at that, and a lot of the galaxies, the reason they look somewhat fractal is because of the repetitive things that go on, right? I mean, you have reactions.
It's also that Game of Life, Conway's Game of Life thing, where very simple rules can produce incredibly beautiful and intricate structure.
Sure, exactly. And so, the universe, there's it doesn't, again, as one of my, I like to come up with the sayings. One of my favorite of my own sayings, that's kind of egotistical, but one of my favorite sayings that I came up with was, it's not the universe that's complicated and paradoxical, it's our theories, right? It's basically, so let's see here.
This is sort of why the electric universe theory resonates with me. Because we see those structures here in electrical phenomena. We see them at all scales. It's known force that dominates in so many areas,
Right, yeah, but on the other side,
having an effect at larger scales is just ridiculous.
Well, true, but there is another thing about fractals in mathematics that's interesting as well. You can have the exact same, very similar patterns with completely different causes.
Yeah.
And so, that the only thing that I would argue, the only thing I don't subscribe my own self, and I've been around the electric universe people for a long time, and I love a lot of their work. The one thing I do not agree with as much is that just because an electrical current can do something similar at a larger scale doesn't necessarily mean that's what happened, because we do have proof of things that are similar but end up from very different reasons. And
the list of confirmed predictions is growing.
No, that's absolutely true. That's true. But again, if you look at a model like ours, that's part of what's going on only. It's not all of it. And I think the only thing I would say to people in the electric universe is just be careful that to say everything is electrical. What a physical model, the electric universe still has positive and negative. If you talk to Walt Thornhill, he's still going to have positive, negative. And to us, that's a convention. It's not real. Just because I put a plus on something and a minus on another, or having a field and not give a physicality for it.
The guy you mentioned before, I can't remember his name, who was doing
Walt Thornhill?
No, the spinning
Oh, yeah, that's Yonel Deneau.
Yeah. That, I think, is a very fruitful area to explore.
Absolutely. In fact, in our book, in fact, I think I came up. I'm the one who coined it. The Deneau effect.
Chirality is a fact of nature,
Yeah, absolutely. No, absolutely.
And some things are right-handed, and
absolutely.
In fact, for each other, and this may be the basis for dielectricity.
Yeah, again, you have to have a physical model for it.
Yeah,
Here's
sure,
the
sure, I agree. I'm just suggesting that it may be a possibility.
Yeah, here is I wrote it in HTML5 actually, two circles, and each of these little points has a direction vector. And in what I have coined the Denis effect, named after Lionel Denis, which I found out about in 2008 and went nuts about. It became part of our model. So it is a definite part of our model, and the Denis effect is everywhere. The Denis effect is magnetism. The Denis effect is polarity in atoms and molecules. So it's the flow, it's the meeting of flows, and the cause of it being the stability from that. So that's part of our model. So absolutely, this person is saying "dig by Sir Chicken." I love I put my real name. I'm so sad. Fractal patterns reveal growth. A sunflower tree grows. Yeah, that's chirality, actually. If you want to read about that, a really good person on chirality, actually, Axeman, is very good, is Bill Lucas. He has a lot, he talks a lot about that. And even though he's all math, and I'm not into that side of it as much, come on, where is his book? His book is big, and I always put it somewhere. All right, but again, Bill Lucas, look up his book. He talks about chirality a lot. And in fact, the right-hand rule why is it that when you have a flow through a wire, there's a right-hand rule? And actually, in our particle model, my father and I came up with an explanation about that flow. And it turns out that the flow of these particles that are going through the wire, what people call electricity, some people call electrons. We gave it another name because it's a more general particle, but it's because of the path it's following, just like suns. If you were to line all these suns up around, there's a gravity field that's even below our gravity field, and they end up spiraling out, and that spiraling, because of a direction, gives a right hand or left hand rule, whatever. Let's see what else we have here on comments. We don't know what causes the structure of positive and negative. What is causing that? The laws of electromagnetism are useful, but again, they are descriptive models. That's an easy answer. Plus and minus are just a convention that we say, for instance, that an electron stays around a proton because one's positive and got a charge and one's negative charge. That's just magic. It's actual magic. There's no reason given for that. And to give you a simple model like ours, the model, what we have, there's one level below, we have what we call G1 particles going in all directions. And those cause a gravitational field. What keeps an electron or a G1 particle around a nucleon or a nucleus of an atom is simply another G1 particle. It's just much smaller down below, another level down. And therefore, it's just like it actually just has a gravity that's not the same gravity. It's what you do is you have levels of the universe. So it would be like gravity. Let's say there's gravitons that keep the sun, the Earth going around the sun. Well, what keeps the atom, the electron going around the proton is, in our model, again, I'm using conventional names, so we don't use those, is another particle, but it's not the graviton. It's the graviton one level down that's much smaller, way smaller, and much faster, maybe c squared, in fact. So, what we have is literally, if you go down a level, the nucleus of an atom is like a sun, and the electron is like the Earth. And the only difference is that what keeps it going is a level down. So if in fact there's a G2 particle, we believe that's what's the nuclear strong force, and below that there's another level. So that's again the infinity. So if you have a model like ours, we don't have positive and negative. The reason those particles stay in orbit is because there's a field, a gravitational field. A gravitational field is what keeps things in orbit. We see that at the subatomic level. We see that at the our level, our universe level. So why would they be a different mechanism? So we use the same mechanism. So that's just one answer. I don't know other models because I don't see other models solving that problem. But I'll tell you, get knocked down, drag out fights with people who are saying, no, charge is fundamental. It's a fundamental force. You don't need to give it a reason, but that's not true. Let's see here. Let's see. I am not arguing galaxies can form the same way, but they're having their own discussion. But on an elemental scale, down to the grain of sand, the chances of a sunflower existing. Yeah. Again, please read Borkert. He will talk about that. The thing that I love about Borkert, he's a philosopher. He wrote the most important scientific philosophy of our generation. Not even close. No one's even gotten close to him. He's got the 10 assumptions of science. And I have go to Dissident Science, Borkert, or 10 assumptions, whatever. Look that up on YouTube. I have a great video on that and talk about that. You need to know Borkert's 10 assumptions. Consupponability. Wonderful. You'll love that one, Axeman. I love that word, consupponability. It means that your assumptions have to be congruent with each other. They have to be consistent and not paradoxical. Let's see. Let's take one that is special relativity. People who say that it's okay, well, take a look at its two major assumptions, and they are not consupponable. And why is that? Because the first one says that the speed of light is measured the same no matter what your inertial frame. So if you have a flashlight and it's on a train, you are going, if I'm on the train, I'm going to measure the speed of light as c. And if you're moving on the train and the light is moved, and you're watching me go by and the flashlight, you also are going to measure that light, and they're also going to be c. And then he goes on to say the second postulate or theorem or assumption of special relativity is that all physics is the same in all inertial frames. And of course, you have a real big problem right away, because the prediction of those two things requires that my time slows down and yours is different from mine, which immediately says that time is not the same in your inertial frame as in mine. And how can that be if your initial assumptions are set up? So the actual assumptions make predictions that are paradoxical. And then if you read Dr. Karazani's work from, he's from Argentina, he's a physicist. He shows one really simple idea, and that is there is no such thing as an inertial frame. There's only one three-dimensional space. This is my interpretation after reading his works for 5 years and trying to figure out what he was trying to say in Leisman's terms. But basically he says the moment we draw two reference frames, the way everyone draws them for special relativity, you are then making something artificial. There's no...
You've thrown away any kind of objective measurement.
Yeah, well, what it means is that for you to measure something, you got to you have to create an arbitrary, another frame, and then you have to measure through that, and then it's moving, and then you start doing all kinds of weird things. And the rule is in the universe is if you see an explosion and you're on a plane, and I see an explosion and I'm on the ground, it's still the explosion. It doesn't change.
What are the units for the speed of light? Meters per second.
Right.
So what happens when you define distance in terms of something that forms the defining units of something? It's a self-referential definition. Sure. You don't know anything anymore. You've just thrown out all rationality. That we arbitrarily create these frames of reference, systems of measurement, units of measurements, in order to have some sort of standard by which we might compare measurements from different places and stuff. If you throw away that, you throw away all physics.
Right. And in my film, there's a German physicist, philosopher. He's wonderful. His name's Peter Marquardt. And he said something in the film that was very good. He says, relativity is a theory of events, observation. It's not a theory of events. What it cares about is the watching of them and the measuring of them. It doesn't care about the events themselves. And so that's truly bizarre, since what you end up with is and many people have said this about especially special relativity, that really it's a you're trying to talk about observation, and then that observation somehow changes the physics around you, and that's what quantum mechanics does as well, because they have no model for light, they have no model for gravity, they have no model for electric fields or
This is
magnetic fields. They end up with
of the uncertainty principle.
That's part of it. Part of the uncertainty principle, part of it's not having a model. Let me tell you, one of the problem with quantum mechanics comes in that they think they're shooting one photon and measuring one photon at a time. They think they're shooting one electron at a time, and they're not.
Yeah, no, that's right. And there's no way that they can prove that any amount of light that they send through their system is directly connected to whatever they split off by a mirror and send to some other detector or anywhere. It's just nonsense. I had a look at the methodology of some of these experiments. What is it? Quantum coincidence, quantum time reversal thing, where they claim to reset the state of something after it happened.
Oh yeah, they have quantum eraser, history eraser.
The methodology of the experiment is just an absolute farce. These are just blip noises in something that they call a detector, that they define an area of time over which, if it happens in that time, they'll say it's a positive result. There's no actual causal link between the two photons. It's a coincidence detector.
Of course.
Now, use a coincidence detector, man. It's just a statistical, it could just be random quantum noise.
Yeah. Let me tell you a story that you would be very interested in. In the mid 2000s or the early 2000s, we were at a conference, an MPA conference at the University of Connecticut, and it was some of the older guard. A lot of them are gone now. But one guy got up. He went to the conference. I actually interviewed for the movie, and he decided to pull out because he was worried about his reputation. But this is what he said. He is a photonics expert. All he has done for 35, now it's 40 years, probably over 40 years, has spent his life working with light. And he stands up at our conferences, and I'm going to paraphrase. You're going to laugh your head off. This is what he said. He said, when somewhere in the universe, something gives off a photon. We have no idea what that photon is. We have no idea. This is a guy who spends all his life with, he's being totally honest. He says, we have no idea how that photon, where it was, how it was released, and how it started. Then he says, once it's traveling through space, we have no idea how that happens. And then it gets to our detector. Our detector goes off. We have zero explanation for why that happens. He says, that's what we know about light. And this is a guy who, he's being totally honest. And he said, here's my experiment. And this is where in our model, we don't have like one electron around a nucleus. We have lots of other particles. It's a quantum of particles. A sun can hold so many. That's the way our model works. Fine. But what he said is this: here's an experiment that's going to blow away physics in general and photon. He says, so I want to do. He didn't do the experiment. We should do the experiment. I don't think it's that hard. We're looking at trying to get some funding toward us, and maybe we should do this experiment. Here's what he said. They have one photon detectors. One photon detector, Axeman, is not a one, but he's admitting it. He says, we're going to do this. Don't take it as we're going to detect one photon. He says, we're going to take what we call a one photon detector. And everybody in particle physics and all of standard model people will all agree this detector will detect what we call one quanta or one photon. I'm then going to take 5 emitters, and these emitters we know would give off the energy of a photon in electromagnetic waves. But I'm going to take 5 of them that are 1/5 the energy of a photon. Okay, so he said this is a photon. This is the same guy. He says I'm going to take 5 photon emitters, but I'm going to put them at 1/5 capacity. And then I'm going to point these 5 1/5 capacity
What's 1/5 of
photon
a photon?
and point them at the one photon detector. He says, if that photon detector goes off, all bets are off on the photon. I mean, that's just such a brilliant and simple experiment. It goes to show you, and that's why, like I said, in our model, when we look at even electrons, here's an example. People said, Dave, why does your dad and you have a particle that is, well, I mean, why is it that you would have more than one going around a nucleus and call that a hydrogen atom instead of just one electron? I said, it's really simple. Did you ever take a look at the periodic table? Do you see integer numbers for those atomic numbers? Oh, you don't. So how is it that we have perfect electrons and perfect protons, yet the numbers don't come out even? And so people are going, wait a minute. Yeah, that makes sense. Well, the reason is our models need to be
atomic weight, atomic mass.
Yeah.
So that's an average of the distribution of over the distribution of isotopes.
Well, that's what they say, right? I mean, what I'm saying is, though, is when you look at the action, for instance, like the electron, one of the things about the electron is saying, wait a minute, how could our model be saying? And we were looking at the way our model was coming together with the principles of infinity, the Denew effect, and my father's wave particle duality solution. We put those together with Newton stuff and said, okay, what's that model look like? Well, one of them was saying that, well, you know, the electron is really probably not one particle. It's more of a bunch of particles, you know, together. It's just a sort of a quantum. Well, what happens is when I went to look at the electron, I said, okay, what is the definition of saying that an electron is a particle? Well, when you talk to Dr. Lucas, he is a doctor in science, you know, physics, and he says something that the way standard model, how does a standard model say that this is a particle? That you can make a beam out of it. That's what they say. So if you can make a beam out of something, they claim that's a particle. Because if it's a wave, of course, the wave would spread out. So that's what they said. So I took a look at the beginnings of what people said, what they found was the electron. What you find is that you find all kinds of ways that you think that you are finding one of them. But if you really look at the experiments they're doing, there's really no proof that this is one electron. What they find is how things react with beams of electrons. They try to look at stuff. They try to come up with their ideas. But when you come down to it, if you really look at the properties of what the electron is, it's extremely nebulous, extremely so. And so, in fact, it's called one of the fundamental
measurement problem, and building things upon assumption, built on assumption, built on assumption.
And I'm not saying that it's wrong. What I'm saying is that if you look at it, it is, you know, if you ask a student or an average person, do we know a lot about the electron and its properties? Of course we do. We know it down to the radius and to all kinds of things. You know, it's like half spin. You know, there's a wonderful characteristic, half spin. Is that like spin halfway and stop? But I actually had somebody explain that one to me. They said half spin is when you take a sphere. This isn't a sphere; it's a dome. Oh, I can't get to it. There you go. It's like this. Half spin is when you're measuring up here, not at the equator. That's what somebody in standard physics told me. I thought, okay, you know, half spin. I mean, think of it physically, what that means. It's just bizarre. All righty. We're coming up, oh my gosh, on 2 hours. I usually like to stop it at that. But anyways, let's see. I agree with Destini. You cannot detect, let's see. You cannot detect a single photon, never, ever. Yeah, I do have one called the impossible photon. Take a look at it. Frequency, by definition of what frequency is in the colors, it's information. Information can't be sent as one particle. So, yeah, it's going to be a lot of particles. My dad has his solution. Basically, not photons, but light is just waves of particles traveling at the same speed, just like, you know, shower on massage. You know, I can send Morse code to you in spurts of particles. You know, that's basically what we do in digital. And so that's what light is. It's just waves of particles traveling together in our model. In ether models, it's waves through a medium, but of course that's hard. Ether models have a real hard time with a laser. I don't know how they do that, so that's why I'm not an etherist myself. Well, listen, Axeman, thank you so much. It was great to have you here. I just absolutely enjoy talking with you. I would really suggest, I'm not sure if we're going to have a physical conference, or we may try to use this technology and then set up an entire conference, and instead of people traveling, but to do it live on the internet, because people traveling, it's just so hard and it's expensive to get people together. But I'll think about it. But I certainly enjoy talking with you. If you have any ideas you want to put down in papers at any time, I think it would be wonderful. But keep up with the great critical thinking. If there's anything you do want to write, we've got Science Woke, where I'm willing to have people like you write some articles about what you're talking about. I'd really like, think about this.
I haven't thought about it, to be honest.
Here's what I'm going to tell you. I'm going to pitch this idea to you because I really like this. You're talking about limited hangouts, doctrinal change in course. These things can obviously be related directly to science as well, because that's obviously an interest of you, especially in the electric universe world. How about writing some articles in that vein?
It informs all fields of knowledge.
Of course. Yes, but it's still worth it to have. And I think these would be wonderful articles for us to put on the Science Woke, and you could be the person doing it. If you want to do it in a pseudonym, that's no problem. I don't care.
It's a pseudonym. I keep myself pretty anonymous online.
So that's no problem. I would keep that in anonymity, but I'd love to have you write some stuff. You really have some brilliant thoughts. Very much. Think about it, okay?
Yeah, I will.
All right, good. All right. Okay, I'm going to take you off there and wrap it up here. So I want to thank everybody, all my subscribers. I promise I'm going to be getting my videos out. I've been just busy with life and stuff. I do appreciate the interaction here. I was able to quiet down our Mac guy. Unfortunately, you get those kinds of people. In general, I really appreciate people's feedback. I do look at it, and if you would like to come on and speak like Axeman has done, you can when we're next Friday. If I'm here, if I find my Fridays are open, I will do that. If you want to check out and read about it, if you're new to this, go to sciencewoke.org. That is actually sponsored by not Wiki Natural Philosophy, but naturalphilosophy.org. I think I've got that somewhere. But you can go to naturalphilosophy.org, not Wiki. That's our Wikipedia. You can also check it out there. And everybody is invited, of course, every Saturday. In fact, tomorrow morning, I think I'm going to be the one in charge of it. Usually it's Franklin Hugh. That's where you get into the real nitty-gritty of real models of the universe we talk about. I try to get more on the general side, but I will be leading that, which is we've been doing that for over 10 years now, every Saturday morning. The time frame is not good, I think, for Australia, unfortunately. It's 10 a.m. Eastern time to 12 noon, 7 a.m. Pacific to 9 a.m. And then in Europe, it's in the afternoon. Australia, unfortunately, on that one won't work. So it's sort of good that I'm doing it one at night as well. This is also streaming to streaming directly to Dissident, my YouTube channel. So if you missed this, you can immediately go back and take a look at it. It was really great discussion with Axeman and some other people too, to take a look at one of the articles that came out. But greatly appreciate your support. And if you're interested in helping out in any way, let me know. There's all kinds of things that we can do. But I want to thank everybody again. And, remember, folks, I am your science therapist trying to get you the promised land of becoming a critical thinker in science, opening up your brain. So take care and ciao for now.